All right, let's look at the homework 4.4, problem number 2. All right, so we're going to use the convolution property to find the inverse Laplace transform of S over quantity S minus 3 times quantity S squared plus 1. All right, so let's look at the S over, all right, quantity S minus 3 times S squared plus 1. All right, so I'm going to split this into 1 over S minus 3, right, times S over S squared plus 1, right? So this is going to be equal to Laplace transform of, right? So first one is a Laplace transform of e to the 3t. And multiply by Laplace transform of cosine of t. Right? So if you want to find the inverse Laplace transform, so all you have to do is this. So you take the inverse Laplace transform. It's going to be simply e to the 3t convolution with cosine of t. Right? So by definition, this is going to be an integral from 0 to t, e to the 3 tau times cosine of t minus tau with respect to tau. Right? So we're going to use the integration by parts. So I'm going to take the derivative of this. You get 3 times e to the 3 tau. Take the antiderivative of this. Antiderivative of cosine is sine of t minus tau. And then divide by derivative of this guy with respect to tau. It's going to be negative 1. So actually, I'm going to actually write it as a negative sine of t minus tau. Right? So by integration by part, right, we're going to get, right, so we're going to multiply those two guys. So it's going to be negative e to the 3 tau sine of t minus tau. Right? Then we know that this is going from 0 to t. Right? Minus, there's a negative sign here, so it's going to be addition. And then we have an integral from 0 to t. Right? So you have a 3 e to the 3 tau and multiply by sine of quantity t minus tau with respect to tau. Right? So let's evaluate this part first. Right? So plug in t here. Right? Plug in t, so you have a negative e to the 3t. But here, if you plug in t here, sine of 0, which is 0. So we get 0. Minus, but there's a negative sign here, so it's going to be positive. And plug in 0. E to the 0 is 1. And the sine of t minus 0. So it's going to be just simply sine of t. Right? So this is going to be sine of t. Maybe I'll to make it simpler. So this is going to be sine of t. Right? Then unfortunately, we're going to have to use the integration by parts one more time. Right? So I'm going to take the derivative of this guy. You have a 9 e to the 3 tau. Antiderivative of this guy, you're going to get the negative cosine of t minus tau. but divide by negative, so it's going to be actually positive. So I'm going to just erase that. All right, so this times that, so we're going to have 3 e to the 3 tau times cosine of t minus tau, right, from 0 to t, right, minus, right, this times that. So 9 is just a constant. I'm just going to bring it out here. Right, then you have an integral from 0 to t, e to the 3 tau, and you have a cosine of t minus tau. Right, so we have that. Right, but you notice that we get exactly the same integral. So let's say this is the integral we want to find. So we're going to call this guy I. Right, here this is an identical integral popping up again. So this is going to be equal to I. So what you get is, since we're looking for I, you have negative 9I sitting here. So what I'm going to do is I'm going to move this term over to the other side. So I'm going to add 9I to both sides. So initially, left-hand side is I, so you're going to get the 10I. Right? Then you get the sine of t is still there. Right? Then here, we're going to plug in t. So you have a 3 e to the 3t. And then you have a cosine of t minus t. So cosine of 0 is 1. So you just get that. And then minus, right, you have a 3. Right? E to the 0 is 1. And then you get cosine of t. Right? So what you're looking for is I. So we're going to have I. So we're going to divide through by 10. Right? Remember that the I is the convolution we're looking for. So the convolution we're looking for is I. Then you're going to have 1 over 10. Right? For some reason, they decided to put 3 e to the 3t first. And then you put 3 cosine of t next. And then we have a sine of t. Right? And that's the inverse Laplace transform, because this is the convolution of e to the 3t, convolution cosine of t, and which is the inverse Laplace transform of given fraction, the rational function here. All right, that's it. I hope that this was clear.